Number 912, shorten array. We have the integer array, and then we have to sort the array in the ascending order. So we have array integer nums in ascending order, nums in ascending order, and we have to solve it in n log n time complexity. The smallest base complexity without any using built-in functions. So there's a lot of way to solve this. So we can use shell sort, many algorithms for this situation, like quick sort, but I want to use the merge sort, the in-play merge sort. I will use the in-play merge sort in this case. So a normal merge sort is will cost on of time complexity, space complexity, but the in-play merge sort only costs equal 1 time space complexity. So our idea is to just like similar to merge sort, we have to split this array into two small array like this, and the in-play merge sort we will have the two pointer for each index in the small array, and we compare them. We compare to this string, and if the right one is smaller than the left one, so we have to move right here. So our goal is to move all of this array before the one right here into the right, shift y one element, so we move 5 by index plus 1, so we have a 5 right here and 2 right here, and we change the first index in the left one into 1, so we have here 1 2 5 3. Okay, so after this we move the next, and we compare, just compare. So because 3 is bigger than 2, so it's in this case it's good, so we will move the left arrow to here and compare, because 3 is smaller than 5, so we have to move right here and just shift on all of element before this by 1, so 5 2. Oh, so this, because the index right here we have to shift until the point right here stop at the pointing of the index, so we have right here, so we change 5 into 3, and we have the sorted array in ascending order. Okay, so we have here to implement the merge sort. We have a sort array first, so sort array if low is smaller than high, we return for the recursion, and then we count the mid one, using the recursion to cut the array into two smaller array. So here we have the mid and the order array, mid plus 1 and high, and then we merge two small array into the bigger array. So we have here is low, mid, high, and we will new method called merge yes, a low, mid, and high. So a smaller improvement right here is if a mid is smaller or equal than a mid plus 1. So it means this array is already shorted, so we just return already shorted and just start for the second array with while low is smaller equal than mid and star is smaller or equal than high. If a star is bigger or equal to low, move the low one because it's already at the low position is correct, so increase the index, else okay 10 is start, and we will shift all element to the right. So instead of manual, I want to use this method for a bit improvement to the performance. So just implement stun array low. Oh, this is a low a low plus 1 and star minus low, and a low equal 10, mid low and start. Oh yeah, well, forgot nums 0 and nums length -1 because we are touching the array. We're using the binary 0 1, so we have to -1 and then just return array. We have been sorted. Yeah. Wait, what? Semicolon. Oh, we forgot the equal right here. Okay, submit. Yeah, the very the very complicated solution, but I think it's fun to solve this thing. Just to practice if you want to solve. Okay, time for the analyzing, time complexity, and then the small complexity. So we have right here is the recursion. So the time for the recursion is based on the depth of the tree. So in this case, because we divide the array into the half and half and half, so we have a is log n. And because we're using a loop, a while loop right here, so of course in the upper bound it will be the n time for the worst case. So we have here a time complexity is the big O n log n, and for the space, because we didn't create any the time array right here, so we just remove it. It just called big O 1. And for right here the recursion one, because we're using a recursion, so it's the method will be being stacked, so it will be stacked, and it's based on the depth of the tree, so for each stack. So because we here is log n, log n the depth of the tree, so we have like a big O block n time complexity too.